Hi guys, this video is going to be on graphing piecewise functions. So piecewise functions are functions that have different parts put together on the same graph. So if you look at this here, it says f of x equals, and then it has this curly bracket thing here. So basically f of x is three different functions. It's going to be f of x equals 3 or y equals 3 when x is less than -2. It's going to be x squared minus 1 when x is between -2 and 2. And it's going to be x plus 2 when x is greater than 2. Okay? So we need to be able to look at these functions and graph all of them, but we only want to graph certain intervals of them on the x-axis. Okay? So the first thing that you'll want to do when you're looking at a piecewise function graph is you're going to want to determine where the x values are changing. So it looks to me like we've got a change at -2 and +2, right? There's a +2 and -2. So I'm going to come over to my graph, and I'm going to put a dotted line here at -2. Now this dotted line is not part of the graph, and the only reason I'm drawing it there is so that I know where this stops being one function and starts being another. Okay, so then I'm going to put one at +2 as well. Okay, so basically what I'm doing here is I'm graphing three functions, all three of these, on the same graph, but I'm only going to put parts of them there, depending on what their x values. So, for example, f of x equals 3. Okay, so f of x equals 3, if I just look at that top line, this is my function. Remember, f of x and y are interchangeable, so f of x is just the same as y. So the first function is just y equals 3, right? So y equals 3 just means I'm going to come over here and I'm going to go up to y equals 3, right here, 1, 2, 3. And then I'm going to draw a line that should be a straight line, and it'll be right on the line, right there. So that's the function y equals 3, okay? Now, I should have only put this there when x is less than -2. So here's the line x equals -2, and less than that would be on this side, right? So that means this is the only piece of that graph that I want. So I'm going to write above here y equals 3 because this is the interval of the graph that I want. So the rest of this right here, because it's not less than -2 right there, all these x values are greater than -2, so I don't want those parts of that function over there. So what I'm going to do is I'm going to erase this part and this part. Okay, so even though ordinarily this function, y equals 3, would go all the way across, because I have this domain stipulation right here, I only want that when x is less than -2. So I'm only drawing that part. Now notice again here that my inequality is just a less than, right? And because of that, I know there's going to be an open circle here where it meets this line of -2. So I'm going to put this as an open circle. If that said less than or equal to, then I'd want to fill that circle in, right? Okay, so now I'm going to go ahead and I'm going to do the next function. Now the next function is x squared minus 1. X squared minus 1 has an x squared, which means it's going to be quadratic, right? It is, basically I can just choose a few values, right? So if I have a t-chart, here's x and here's y, and remember y equals f of x, they're the same thing. So if my function is f of x equals x squared minus 1, it's the same as y equals x squared minus 1. So I'm just going to choose a few x values to plug in. I'm going to do 0, I'm going to do 1, I'm going to do 2, I'm going to do -1 and -2. I just chose these x values. You can choose whichever ones you want. The thing is that I kind of want them to be between -2 and 2 because that's the part that it says I'm going to be having this function x squared minus 1. So up here we'll write y equals x squared minus 1. That's what we're graphing between these two lines. So I chose values that are between -2 and 2. Now if I put 0 into this function, 0 squared is 0, and 0 minus 1 is -1. If I put 1 in for x, I'm going to get 1 squared, which is 1, and then 1 minus 1, which is 0. If I put 2 in here, I'm going to get 2 squared, which is 4, and 4 minus 1 is 3. If I put negative 1 into the function, negative 1 squared, negative 1 times negative 1 is positive 1, and 1 minus 1 is 0. And if I put negative 2 in there, I'm going to get negative 2 times negative 2, which is 4, and 4 minus 1 is 3. So now I have 5 points I can plot. So I'm going to go 0, negative 1, so that would be right there. 1, 0 is right there. 2, 3 is right here. Now I want that to be a closed circle here, even though ordinarily this function would continue and go up this way. Because I only want to graph it between the x values of negative 2 and 2, I'm going to end it right there. I'm going to stop, and because it says x is less than or equal to 2, I'm going to make that a filled in circle. Then negative 1, 0 would be here, and negative 2, 3 would be here. So now this function is going to fill that one in. So I know that quadratics have that parabola shape. Now I can kind of see how it looks. So it's going to look like this. I do want to put those endpoints into the function to see where it comes up to these dotted lines and how it changes. Again, ordinarily this would just keep going this way indefinitely and they'd have arrows. But because this tells me I want to only between negative 2 and positive 2, the x values of negative 2 and positive 2, the rest here is going to get cut off or truncated. I'm going to just erase those pieces because I don't want anything that goes past negative 2 or positive 2. So that's what a piecewise function is. In this interval, I only want to graph the first function. In the middle interval, I only want to graph x squared minus 1. And then over here, I only want to graph x plus 2. Okay. So now we're going to graph x plus 2. Since it says to graph x plus 2 when x is greater than 2, that means over here, right? So let's get a different color for that. So let's use blue. So over here I'm going to have y equals x plus 2. Now this is a linear function, so there's a couple of different ways you could graph it. I think maybe I'm just going to do a t-chart. And I'm going to choose some x values, and I'm going to see what y values go with it. Now again, remember, I only want to choose x values that are greater than 2 here. And in fact, I want to see where it comes up to 2, even though it won't equal, because it just says x is greater than 2. I know it won't have a closed circle on this line, but it will have an open circle somewhere on this line, and I want to find out where. So I'm going to plug in this x value of 2 to see where it is along this line. So if I put 2 in for x, that's going to be 2 plus 2, which is 4. So 2, 4, so here is where this line is going to come up to that boundary. Now I'm going to choose any of the other x values that are on this side of 2. So I could do 3 or 4 or 5. Let's just do 3. So if I put a 3 into the function, I'm going to get 3 plus 2, which is 5. So I'm going to plot the point 1, 2, 3, 1, 2, 3, 4, 5. So it's right there. Now this is a straight line, so I know I can just go ahead and connect that, and it's going to continue up that way. Right? There's going to be an arrow because it's going to keep going. But when it comes up to the line, it's going to stop because I don't want to graph this one for any x values that are less than 2. Ordinarily, this line would continue this direction, right? And it would have an arrow going that way. But because of my domain stipulation, only when x is greater than 2, I'm not going to include that part of the graph. Okay. So basically, I'm putting 3 graphs on the same graph, but on different intervals, I'm only putting 1 each, I guess. Okay. So here's my graph. Now I can look at this all as one function, even though it's 3 parts, 3 different pieces of different functions. I'm going to look at the whole thing all together as one continuous function, even though it has a hop right there, right? Whoops, I didn't mean to erase that. So now what we want to do is answer these questions that there are down here about this. So the first thing is, what is the domain? So remember, domain is our x values. We look left to right, furthest left to furthest right. So my furthest left point is an arrow that's going to keep going that way. So my domain is going to be negative infinity. And then if I go all the way right, another arrow. So that's going to keep going that way indefinitely. So my domain is negative infinity to infinity. Now my range, that's my y value, so I'm going to be looking at lowest value to highest value, lowest y value to highest y value. So the lowest y value is here at -1. It has a curve that goes through there, right? So that is going to be a square bracket. And then my top value, well, here we have a gap, right? So between 3 and 4, there is no y values touching the function, which means I'm going to need 2 intervals to do the range. But the first one's going to go from -1 to 3. And the second one is going to hop up to 4 and then continue up to infinity, because that arrow is going to keep going that way indefinitely. So I need to erase a little bit here, I've got no room. So I have a range that has kind of skipped some values. So I'm going to go ahead and put 2 intervals so that I can skip those values between 3 and 4, between y equals 3 and 4 where there's no y values. Okay? So 1 to 3, and then also picks up at 4 to infinity. 4 would have a round parenthesis since that's an open circle. All right, so now it's asking me to evaluate the function when x equals -3. So remember, when you see f and then the parentheses and a value in here, this is the x value, and you need to find the y value that goes along with it. So I can kind of use my graph to do that. Like here's -3, so I see that the function is this one. It's y equals 3. So I know that's just going to equal 3. Any value that's less than -2 is going to have the value of 3. The better way to do it, since you're the one who drew this graph yourself and every single point might not be exactly where it's supposed to go, would be to use this to graph it or to find it instead. So what I would do is I would decide which one of these intervals is the value, the x value in. Okay, so in other words, I would say, okay, x is -3. Is -3 less than -2, or is -3 between -2 and 2, or is -3 greater than 2? And we see it's this one. So we would plug x in, but when it's just a constant like this, there's no x, then every y would just be 3. So the answer there would be 3. Now f of 1 is in the middle of, or it's between -2 and 2, right? So for 1, I would plug it into this one right here. So 1 squared minus 1 equals 0. Now because that was one of the points we happened to choose when we were drawing our graph, we already saw on the graph also that when x is 1, y is 0. So both work, but I just err on the side of caution and use the function instead of this one that you drew yourself, because the one you drew yourself may have some points that are not exactly on where they're supposed to be. F of 4, when x is 4, that means x is greater than 2, because 4 is greater than 2. So on that one, I would use this function, x plus 2. So f evaluated at 4, the function evaluated at 4 would be 4 plus 2, which is 6. Okay. So you don't just plug x into like all of these. You have to find which interval your x value is in using these inequalities in order to find which one to plug it in to find y. Okay. So let's do one more of these. Because I think this is a kind of a new concept. It can be a little tricky, but I think you guys can get it. So let's try one more. So we have f of x equals -4 when x is less than -3. F of x equals x when x is between -3 and 1. And f of x equals -2x plus 3 when x is greater than 1. Okay. I swear I had a graph on here. Let's see if we can make it come up. There we go. Okay, so the first thing you want to do again is we want to break this x-axis up so that we can see where one function should start and end. So we want y equals -4, right? That's our function, when x is less than -3. So I'm going to put, again, a dotted line at -3, and this is just to remind me where the change should happen. It should be one function until I get to that line, and then it should change to another one. It's going to be x when x is between -3 and +1. And then when it's greater than 1, it's going to be -2x plus 3. So let's start here with y equals -4, because that's the one we want to graph when x is less than -3, so on this side of -3, right? So y equals -4 will just be right down here. So it's just the horizontal line at y equals -4, and it's going to stop at -3 because we only want to graph this one when x is less than -3. So when these x values are less than -3, that's when we want this function. Okay, so there's that piece, and my line is horribly unstraight, but that should just be a straight horizontal line that heads over that direction. So now our next one is when x is between -3 and 1. So on my graph, that's between -3 and 1 here. And so that's going to be y equals x. So let's actually change colors here, do the next one in a different color. So we're going to graph y equals x in the middle. So again, let's make a little t-chart. So here's x and here's y, or f of x. My function just is y equals x, right? Which means when x, and always choose values between -3 and 1. So let's do the endpoints. When x is -3, y is -3. When x is 1, y is 1. When x is 0, y is 0. Okay, so let's just plot these points. So I've got -3, -3. So again, that one shows me where it comes up to this line. So because it says when x is greater than or equal to -3, we'll fill that in. I've got 1, 1, 1, 1. Again, when it says x is less than or equal to 1, I fill my point in, and then we'll have 1 through 0, 0. But because this is linear, right, it's just a straight line. Oops, that was not 0, 0. So let's erase that one. I was like, that does not look like a straight line, but it's because I was thinking the origin was a different point than it actually was. Okay, so there we go. So 0, 0. So basically our straight line is going to go like this. So that's going to be our middle section. Again, ordinarily this line would just keep going both ways, but we only want to graph that line when x is between -3 and 1. So we'll cut off the rest on both sides. Okay, our last function is -2x plus 3, and we're going to graph that one when x is greater than 1, so on this side of x. So we're going to graph y equals -2x plus 3 in this section over here. So let's do another t-chart, -2x plus 3. And then we're going to have our x's and our y's. Again, we need to choose x values that are 1 and bigger. And then again, even though it says when x is greater than 1 and doesn't include 1, I still want to know where it comes up to this line. So I am going to plug in 1 to the function. So that would give me -2 times 1, which is -2, and -2 plus 3 is 1. So 1, 1 is on the function. So it would be an open circle for this piece, but since it's already filled in, it's going to be a filled-in circle. And then I would want to choose values on this side, right, bigger than 1. So let's do 2. So -2 times 2 is 4, -4, and -4 plus 3 is -1. So 2, -1 is a point on the graph. And because it's a straight line, I really don't need to keep going, and I know that it's just going to keep doing that, right? So go ahead and draw that line in, and hopefully you hit your points better than I do, because it's a little bit hard with this marker. So this is going to be our piecewise function. So now we're going to look at the domain. The domain would be the furthest left x value, which is -∞, because it has an arrow that's going to keep going. The furthest right would be that one, so it's going over to x equals +∞. Now the range is lowest to highest, lowest y value, which is an arrow still, which is going downward, so that would be -∞. And then our highest value is right there at +1. So my domain is -∞ to infinity, and my range is -∞ to 1. I do have a hop right here, but because the y values are included with this line right here, I don't need to do 2 different sections like I did last time. Okay, so f of -3. So -3 is right on the border, right? This one's for when x is less than -3. This one is for when x is greater than or equal to -3, right? And so because it's equal to -3, x is equal to -3, I would need to plug it into this one, which means that y equals -3. When x equals -3, y equals -3. That's that point right there, right? So make sure you're looking up here, though, and don't rely on your graph. try to find which interval the x value that's given is in, and then plug it in the corresponding function. So when f is 0, 0 is less than 1 and greater than -3. So again, it would be this middle function. So just plug in 0 right here, which means y equals 0. And then when f equals 2. So when f equals 2, sorry, when x equals 2. When x is 2, it is greater than 1, so I would plug it into this one right here. -2 times 2 is 4, and 4 plus 3, sorry, -2 times 2 is -4, and -4 plus 3 equals -1. Okay, so just, again, rely more on the equations for finding those than you do on the graph, although technically both will work. It's just that since we drew the graph ourselves, sometimes we might not be able to rely on every point being exactly where it's supposed to be. All right, guys, that's it for today. Go ahead and try the worksheet, and we'll see you next time.